number 8. Dun, 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 dun. Find below, removable discontinuity if the function doesn't have a removal. Have a removable discontinuity. Let me share this. Okay, let's read it. Yeah. If the function does not have a removable discontinuity, type in n below. Otherwise, state the value of GA. Actually, yeah, I need to share my iPad. We need to show some work. But let's read it first. All right. Okay. So our job is try to figure out, is there a hole there? And if there is, tell us how to remove it. Okay. So let's figure out the 4 of them. First one, f x a equals -2. So what we want to do is we want to simplify it and plug in -2. See what happened. We're plugging a equals -2. Can you see that? It's not possible. Therefore, there is a hole. And once you remove the hole, this is nothing but x minus 4. Sounds good? Okay, that's the first one. Now the second, fx equals x minus 7, x minus 7 at x equals 7. So what we want to do is we want to take limit x goes to 7, x minus 7, x minus 7. Then we try to see, well, what's the limit? From here we can see we have to do it both ways, the left and the right. On the left, we should take this and negative this. On the right, we should take positive this. So we have 1, we have -1. That means on the left it's -1, on the right it's 1. Maybe a hole here, maybe something continuous here. Can you see it's not a hole? It's a remove, it's a jump. So the second one should be n. N. Okay. The third, again, you can plug in, you'll find it's 0 over 0. So there is a hole there. To double verify, you have to know a formula that is a plus b equals a plus b, a squared minus ab plus b squared. Okay, this is only for homework. For the exam, you don't have to know this formula. But if you know it, then good so far? If that's the case, the original thing will become this thing, and this thing cancel each other, giving you only this one left. So the answer is going to be x squared minus 4x plus 16. And there is a hole. Once you cancel, it's gone. Okay. Finally, the last one. Then what you need to do is, for this one, clearly it's 0 over 0 times the conjugate. And it's easy to see the top become 9 minus x, which cancel with this one. You have 1 over 3 plus this. Sounds good? The rest is plugging the corresponding a to find the limit, because they're not looking for this format. They're looking for, if you plug in a, what number do you get? Okay, so just plug in and you will be fine. Sounds good? Cool. Any other questions from homework? All right, let's continue and finish 2.6 today. We talk about limit at infinity. Something look like this. Of course, you have a negative and positive infinity. So technically you have two. Then we figure out they're nothing but horizontal asymptote. If you have a number, we have at most two. Then we talk about how to calculate limit at infinity. We kind of started from simple function. Okay, our job is go into our knowledge and try to see, do we know any horizontal asymptote? And we found the following. Exponential, on the left, it's 0. Arctangent, have 2 horizontal asymptote. Here is negative. Because of the graph of side snake. Number 3, the fact, limit x goes to infinity, 1 over x to the r equals 0 for any r bigger than 0. That tells you 1 over x squared, 1 over x, 1 over square root of x. As long as you have an x some power on the bottom of a fraction, it's 0. Okay, that's the second one. Then we talk about how to use this simple fact to do something more complicated. That is leading term. Okay, the idea is quite straightforward. We have something. Okay. A simple calculation shows that the top is infinity plus infinity minus infinity. The bottom is infinity plus 1. Okay, clearly it's infinity over infinity. But then what we say is, well, you have so many terms, but really this one dominates x squared, dominate 4x. And this one dominate x, dominate 1, because they are the leading term. That means when x goes to infinity, compared to the first one, the rest doesn't matter. You are small. Okay. And the colorful way to show that is on the top and the bottom, we divide both by something we call a leading term. In this case, on the top is x to the cube, on the bottom is x to the 4th. Together, it's x to the 4th, the bigger one. After that, we try to use algebra to factor everything out. Okay, now we see the advantage of dividing by leading terms, because you're dividing by the biggest term. what's going to happen? Well, the leading term divided by itself is going to give you a number. Anything else divided by the leading term, because it's a leading term, anything else is smaller than the leading term. So once you divide it, it's going to give you some fraction with some additional leftovers on the bottom. Make sense so far? For example, x divided by this, because this is leading term, you still have some x left. You have 3x left. Okay? With that in mind, when we finish this, we know this is 0, this is 0, this is 0, this is 0, this is 0. So together it's 0 over 6, which is 0. Okay? That is the idea of leading terms. The key are the following. Number one, you need to find the leading term using algebra. Number two, you just need to rely on a simple fact. That is, once you divide by the leading term, anything has a leftover on the bottom goes to 0. Once they're all gone, what's left will be just the leading term. Sounds good? In the exam, this is the solution you show. We call it complete solution. You need to show every single step of this, okay? Because you need to rely on this fact. Of course, if you want some shortcut, let's take a look at what we're really doing. Clearly, to show the steps, you have to divide by x to the fourth and x to the fourth on the bottom, right? And go over all the long process, which is pretty long. Sounds good? But according to our experiences, once you do that, what's going to happen? What's going to happen is all these terms doesn't matter anymore, because more or less you have some x on the bottom and you become 0. Good so far? So what we just did is equivalent to just focus on the biggest one and just figure out what happens to them. In this case, they just cancel. The answer is 6 over 5. Make sense so far? Okay. This cannot serve as a complete solution because you use some shortcut. But if I don't ask you to show the work, you can use this one quickly. Okay? There's no stopping you from that. The idea is just only the biggest one matter. Thanks to when x goes to infinity. In general, every term matters, but when x is big, only the biggest one matter. Okay. Now, I won't show all the details. I will just do some example really quickly by seeing what's going on. Number 2. What's the limit? X goes to infinity. X minus 1 to the cube, x plus 2 squared divided by 2x minus 3 to the fourth times x. If I don't ask you to show any work, remember you just need one term on the top, one term on the bottom, and make sure they are the biggest. What's the biggest term on the top? Well, hold on. What's the answer? 3. Yes. Okay. And then you keep following things out. You just keep going, keep going, keep going, keep going until you get all the terms. Then you take the biggest one. Make sense so far? That's definitely something you don't want to do. Okay. So now wait a second. I really don't care about what are the terms. I really care about the biggest one. That's just one term. What's the biggest one here? X cubed. What's the biggest one here? X squared. What's the biggest term together? X to the 5th. Make sense to everybody? Everything else will have some like x fourth, x cube, x squared, but really I don't care. I just care about the biggest one. And that is the exact one I got. So it's actually easier than what we thought. Okay. What's the biggest term on the bottom? That's going to be, number 1, 2x to the 4th. This 2 go with it. Okay. Times x. Now 16 times x fourth times x. Together it's 1 over 16. Sounds good? Okay, so from now on, if you have a shortcut to do things like this way, you really don't have to show all the work of FOIL things out. It doesn't worth it. Okay, feel free to do things like this. All right. Second case. Plugging in infinity minus infinity divided by infinity. It's difficult. Okay. Then leading terms. What's the leading term on the top? X. What's the leading term on the bottom? Well, these are the two terms, right? Out of these two, which one is bigger? The square one. Then the leading term is going to be this. The one doesn't really matter. Still okay? This gives you x. Similarly, this one gives you 4x squared. From here, you can see it gives you 2x. Together, which one is bigger? They both give you x. The leading term on the bottom is also x. Settled. Good so far? The rest, finish the algebra. Well, the bottom, now to show the complete work, you have to somehow combine these two. One way to do it is remove the square root and split it. Okay, then you have x. You start to have the way to cancel it. But now you should know that this is not going to work because you cannot split a square root. Sounds good? Alternatively, however, if splitting doesn't work, how about we change the bottom by giving it a square root? That's doable. And once you have that, that's doable. And once you have that, there's nothing stopping you from doing the splitting inside. Still okay here? That will be the principle from now on. We do things this way. All right. The key is take this one in by squaring it, take this one in, and finish. Zero. Zero. Adam.
So I mean, I understand everything here, but how would it affect like squaring, like say you were going to negative infinity instead? I mean, do you have to be careful of
Hold
the,
on, hold on, hold on. Let me give you an example right after this.
okay.
Exactly the problem you're talking about. Yeah. Is everything all right here for everybody? Cool. Now let's try to talk about the thing Adam just raised. By the way, it's a very sharp question. So let's talk about it. You have two ways. Number one, limit x goes to negative infinity, x over square root of x cubed minus 1. Sounds good? This one from the beginning, you are doing the square root of something negative. This is not even a question. You just say there's nothing like this because you cannot take the square root of a negative number. Sounds good? Take a look. The inside is square root negative infinity cube minus 1. That is going to be square root negative infinity. Right? Okay, so this is not possible. You will not see a question like this. And if you do, you say, there's nothing I can do. It's a bad question. All right? Now, there's another tricky case, which we should be careful. And that is this case. And let me do the stuff we just did. We know the top is x, the bottom is x. We know it's here, 2. Let me put it this way. Right, and then that's square root of x squared plus 1 over x squared, which is limit x goes to negative infinity, 2 over square root of 1 plus 1 over x squared, which is 2 over this, which is 2, assuming this one goes to 0. You follow what I'm doing? Okay. Now here comes the question. This is 2, positive. Let's forget about what the number is. Just by looking at this, is it positive or negative? The bottom square root of something is positive, right? The top is 2 times negative infinity, correct? So together it's negative over positive. I should have something negative. But according to what I just wrote, I got something positive. Does everybody see what's happening? Now problem, something is wrong. Somewhere through this process, I made a mistake. Okay? I will give you 2 minutes. Read on this and figure out what went wrong. Okay? I will be right back. Just go grab some water. Adam, what's wrong?
So I mean, when you take the square root of the denominator of the entire fraction, I mean, you're essentially losing the negative sign from the infinity. Like when
So
you're putting the, yeah, like the next step in between there. Yeah.
from here to here.
Yeah.
Okay,
'Cause when
let
you
me write down what I just did. I take this one. I said this one equal to this one. All right, you're saying something is wrong here.
I mean, not
Now,
necessarily wrong, just like when you square it, you're going to get rid of the negative, right?
yes.
And then you just need to identify it.
Or how should I correct it?
I mean, you could put a negative in front of the x
So you're
squared.
saying it should be this.
Yeah.
Okay. Does everybody follow? Think about a simple case. Let's think about numbers. Everybody agree here, right? You square the 2, you put it in. No problem. Now, what if you are doing this? Which is still 4. Good so far. But can you see that positive 2 and negative 2 both give you the same answer? But for the negative one, you have to manually add this because once you square it, you actually don't know if it was positive or negative here. Sounds good? That's the only part I think you need to be careful. When you have a negative infinity and you have square root, you put things in, this negative sign is very easy to miss. You should add it here. I'm going to mark it down when you see the notes. Pay attention here. Think about why did I add a negative, okay? But once you have that, you have this, and then there is no contradiction. You start with something negative, you did receive something negative, and the answer should be negative 2. Okay. Adam, is this example corresponding to the original question you raised?
Yeah, that's what I was essentially.
That's the concern there,
wondering.
right? So I think,
Yeah.
you're onto that point. That's very careful. So very good. All right. That's all for leading term. Find the biggest on the top, find the biggest on the bottom. Only focus on that too. The careful way of doing it is through dividing the leading term and do all these kind of thing and make sure that all terms except for the leading term goes to 0. A shortcut, just take the 2 term out, do a comparison, and get an answer quickly. Okay. Some side notes. Sometimes you have to follow things out. Good news is you only care the biggest one, so it's easy. Sometimes you have square root. Don't get scared. It's the same thing. Just take the biggest term. And finally, thanks to Adam, we have a thing we need to be careful with. That is this sign here. Okay. All right. That's it. Leading term is done. Now we just add several more typical problems. Several ones. The first one, limit x goes to infinity, x cubed plus 2x minus 1, e to the x plus x squared plus 1. Okay, if we take a shortcut. Now question, which one is the leading term on the bottom? This? This? Clearly not this, right? Do you see we have a fundamental question here? That is, if I give you a random simple function, you have to know which one is bigger when x goes to infinity. Sounds good? For polynomial, it's easy. 7 is bigger than 6. No question. But when you put something else, e to the x and ln x, and moreover, sine and cosine x, tangent, all together, which one is bigger? That's the question. Which one is bigger, exponential or polynomial? Recall, what do you know about exponential? It's crazy, right? It grows really fast. So we did know this before. If you haven't, simply just memorize this. Exponential, dominate. We put bigger than, we put two of them to indicate that it's way bigger than any polynomial, which is way bigger than any log. Because exponential is fast, the log is slow. As x goes to infinity. Which indicates between these two, select e to the x, which also means between these two, it's 0 because the bottom is way bigger. Okay. That's the first side topic. Second, infinity minus infinity. Answer? Not sure. Depends. Okay. Now recall leading terms. We really like something like this. Some term here, some term here. Which one is bigger? Give us a number. Is there a way to change this to that? Or you just look at this and you just feel the urge that you want to do something. You don't even know that's going to work. You just want to do it. Nick.
Could you do like x to the -1?
X to the negative? What do you mean?
Like to move it to the denominator?
Doing this, right? Does it help? Think about it. Look at this form. What else do we have? You have something minus something with square root. Anton?
Conjugate.
Times conjugate. That's the way. Okay. Nick, you can do the thing you want, but once you do that, you still need to times the conjugate. And either way, we receive the same answer. So that's good. Once we times the conjugate, what's going to happen? Number one, we do have a fraction type now. Number two, the top simplify a little bit. Number three, the top is 1. The leading term on the bottom, what is it? Well, this term give you x. This term give you square root of x squared, which is also x. It's positive infinity, so we don't have to put a negative sign here. Still okay? Together, this is roughly x plus x. The answer is 0. Sounds good? So next time you see something like that, conjugate will not always work, but I would say 99% of the time. Surprise? This is 0? Well, what is this? That's a big number. What is this? That's also a big number, but I can change it to be like this. Still okay? Huge number, huge number. What's the difference? Well, the difference is only this. That's almost like square root of 1 million and 1 minus square root of 1 million. Okay, can you see that as this part become bigger and bigger to infinity, this part is almost nothing. So they almost become identical. So actually 0 makes sense. Cool. Let's change it a little bit. Same thing. But before I put a 1 here, now I put an x there. Still okay? Both are huge. And basically x squared and x squared are the same term. The only difference is a plus x. All right? This plus x, like the plus 1 before, compared to x squared is nothing when x is big. Still okay? Do you feel like this answer is still going to be 0? Same logic? Okay. Think about it. If you think it's going to be 0, answer yes. Reason is probably the same as what we said before. If you think it's something else, answer no. Three against 1, 3 against 2. 4, 4. Is there anybody willing to bet money on? Okay, if no one, go ahead and try to do it. Okay, go ahead and do it yourself. Remember, make a guess before you do it. We want to test it. So definitely don't just do it and get the right answer. Make a guess, then do it. Whoever finished, just raise your hand and we will check your answer. Aaron, what's your answer before you show us your work?
I got 1 over square root of x squared plus x.
And then
So
what's your answer?
infinity.
Your answer is infinity. Do you want to put money on it?
No, it's 0. I'm sorry. 0.
Oh, right. Okay. Then your answer is 0. Yes.
Yeah.
Right. Okay.
Yeah.
Do you want to put money on it?
Sure.
How much?
Million.
Seriously? Do you trust your algebra
Yeah.
that much? Okay. Let's see. Anybody wants to take that, by the way? Let's don't say 1 million. Let's put something reasonable. $20? Anybody wants to take it? Anton, you want $20? Say it's
no,
not.
I'm on Adam's team, so I'll throw $20 for Adam.
What did Adam say? You mean
That it's
you mean
0.
Aaron? You should think it's
Correct,
okay.
sorry, yes.
We have Anton and we have Aaron. Both $20. Okay, who wants to bet against them? Say it's not 0. $20. Who got a different answer? Raise your hand. You just don't want to bet the money. We got 1, Jordan. We got Adam. We got Jack. Okay. You guys don't want to play money at all?
No.
Jordan, what's your answer?
I got 1.
1. Okay. Let's try. Since nobody bet money, I think it's safe. But let's play. Okay. Limit. X goes to infinity. Conjugate, right? That's the first one. That's the second one. Everybody agree? All right. Aaron, what's the leading term on the top?
X.
What's the leading term on the bottom?
Be x squared. Square root of x squared.
Square root of x squared, which is
X.
x, and this is also x. So do you agree the bottom should be x?
Yes.
So together, let's divide both by x. We have 1 over which is limit x goes to infinity, 1, 1, x squared over x squared plus x over x squared, which is 1 over x squared. This is 0, so that gives us 1 over 1 plus 1. Aaron, do you want to bet against my calculation?
No, not really.
So which part you think maybe somewhere we're different? Where?
It would be no, the next one down.
What did you
Yeah.
get here?
There I got what I forgot to do was divide by x. So yeah, it'd be the next
So
one.
it's an elementary mistake, right? You forgot. Yep.
Yeah.
Great. So, but once you add it back in, you agree my calculation is okay. The answer should be 1/2. All right. Jordan, maybe you missed something somewhere.
Yeah,
But
I
now you
just
can see
the +1, so it makes
this
sense.
one you missed. Okay, I see. Here. All right. Cool. Everything you guys missed are simple, right? It's no big deal. My question here becomes like, if you want to make a car or something complicated, which take, I don't know, 20 steps, how can you make sure that the final product won't kill anybody? Because anywhere you can make a mistake, the mistake can be as simple as, you know, I forgot to screw a, or forgot to put some nail there, or maybe I just forgot some small thing, which is very easy to do. But when you put 20 things together, how can you make sure that you didn't miss anything? Okay, think about it. And at least we can do it in one way that is in our mind instead of testing. And that is actually trained by mathematics. Any tiny mistake, you won't get the right answer. So start to get used to it. And you need to start to think about how to bet money on it. Okay, you need to think about how confident are you when you do algebra. There should be something that you're definitely confident. There should be something you're kind of shaky on. You better know which is which. Okay, in this way, you gradually build your tool set. That's what you go, how you approach this. Nick, what's your question?
How do you get the 1 over x squared?
Let me write down here. Take this, make it this, and make it 1 plus 1 over x. Oh, yeah, you're right. Do you mean this? Yeah, you're right. I made a mistake. There's no x. Hold on, what did I do? Yes, there's no x here. It should be an x, not x squared. Yeah. All right. So strange or not strange? This is 0. This is 1/2. You can check. This is going to be 1. So even though this one compared to this one is nothing, when x goes to infinity, actually the size matter. Okay? That's another example to show you infinity minus infinity, not so easy. All right. 2 more examples and we're done. What if you have something combined together? It's easy. I just want to point out here. It's totally fine if you just break them into component. Look at this first. When x goes to infinity, where does this one go? Infinity. Okay. Then you put arctangent here, but you put this one in. Ex goes to infinity because x goes to infinity. And this one is basically arctangent. When the inside goes to infinity, then you know the answer is pi over 2. Sounds good? So if we combine several simple facts together, do it for one, plug the whole answer into the next one. Do it again, take the whole answer, put it into the next one. That's how we do composition. All right. What's the limit? Anyone? What's the bottom? Okay. What's the top? Well, it's technically not 1. It can be 1/2, 1/3. It can be, but it's always between -1 and 1. Okay? But if you don't know what the number on the top is, you do know the range though. What's the answer then? Well, it should be 0. Because no matter what, the top is going to be a number which is finite. Finite divided by infinity, it is 0. But also you feel kind of shaky because even if the top is finite, you actually don't know what that number is. That number keeps changing. Make sense so far? You prefer something not change. For example, 2 over infinity. Then of course it's 0. Okay. So can you somehow quantify the behavior of the top of a sign? You know it's like that, right? This is not a fixed number, but these two are. So how about we divide them by x squared? And then we take the limit. What's this? It's kind of hard to see because your sin x can be any number between -1 and 1. It's not a fixed number. But this is a fixed number, and this is a fixed number, and I know this is 0, I know this is 0. What about the one in the middle? 0, according to squeeze theorem. So even for limit at infinity, squeeze theorem always work. And the hint is still when you see sine, cosine, squeeze. Anton.
Is this how you would like us to show it, like on an exam, or
Yes.
Yeah. Okay.
Yeah. I mean, sometimes if I don't ask you to show any work, you can say, hey, the top is finite. Divided by something infinity, it kind of is 0, right? But in order to show it mathematically, you cannot say finite, but changing. You need to say finite and it's a number, right? So there's no way you can do sine. You can definitely do 1 and the -1. Both are number. The good news is squeeze theorem will make sure that the one in the middle is going to be behaving really well. So this will be the work you need to show. All right. Up to here, that's everything you need to know about limits. Limits are over. Starting from tomorrow, we will start to use limit to try to define the derivative, which is the changing rate and the velocity. Remember, we did it before. But then we say, well, it's kind of shaky. We don't know if h is 0 or not. But now we're familiar with how to take the limit. We can finally start doing this. And this time, we have all the tool we need. Derivative, which is the changing rate. Okay. That will be all for today. Feel free to leave now. I will stay for questions.